Good morning and welcome to the second part of the Teagasc Crops Forum. So this morning we have a great lineup for you, and we have a couple of topics which will be affecting your farm in both the short and the medium term, and will probably play a large part on your farm into the future. My name is Michael Hennessy. I'm the head of Crops Knowledge Transfer in Teagasc. And I'm delighted to be joined by Dr. Gary Lanigan and Eddie Burgess, who will give us an insight.
Michael, I think hit your mute button there. I can't hear you.
Sorry, I must have hit that. Sorry, can you hear me now? So the pace of change has always been steady on farms, and it's certainly been very much so on tillage farms. And we've always been to the forefront of embracing those changes on tillage farms. So many of the changes which have been put into farms have been embedded, which means that when a farmer purchases a product, the new technology is embedded onto that farm. So if you like, think of hybrid barleys, it would fall into that category, whereas other changes are not embedded and take a little bit of effort from farmers to make sure that practice happens on farm. And again, for this, think about tramlines, if you like. So I suppose what we're going to be talking about today encompasses a bit of both, in terms of that we will have some embedded change, but farmers will have to make some of these non-embedded changes on the farms. And we'll hear about those as we go. So you've been hearing an awful lot about the climate action, and we're waiting on the publication of the carbon targets. That's coming up in the next couple of weeks. And no doubt you've been reading about the proposed changes about the new nitrates regulations as well. Both of these are going to have a big influence on farms over the next little while. So before I hand over to Gary, I just wanted to remind you that you can ask questions and answers, and there's a Q&A tab on the bottom of your screen there. So you can ask them at any time during the presentation, and we'll do our best to answer the questions as we go. So Gary, I'm going to hand over to you, and I know you've certainly been a huge part of the climate action modelling that was going on in Teagasc, and you've been an author on the MAC curves for the industry, which is, I suppose, the practical end of some of that modelling. So Gary, you're going to cover a little bit around the carbon cycling on farms and how maybe that can be utilised by tillage farms over a while. So Gary, I'll hand across to you.
Okay, thanks a lot, Michael. Let's share the screen here. Okay. So what I'm going to be talking about today is really about greenhouse gas balance on farms and on tillage farms, and how we can improve them. Okay, so I suppose Michael touched on the fact that we have an upcoming climate action, or already passed climate action bill, which is seeking to reduce greenhouse gas emissions across the entire economy by 51% by 2030. Now, agriculture plays quite a key role in this, because we're essentially the sector is 1/3 of emissions. Okay, currently running around about at about 23 million tons at the moment. Okay, however, the good news for the tillage sector is the emissions from the tillage sector are relatively low. They run at just over around about 1 million tons. So the vast majority of emissions from agriculture is methane produced from enteric fermentation and manure management, and then N2O from fertilizer, dung and urine application onto soils. And it's actually this N2O emissions, laughing gas from fertilizer application, that in fact dominates tillage emissions. Okay, so if we look at the carbon footprint of crops, be they cereals, oil seeds, or indeed fruit and vegetables, what we generally tend to see is that the carbon footprint of crops tends to be quite considerably lower than that of animal-based products, be it milk or indeed meat. So while meat and milk are dominated by this very large area here, which is enteric fermentation, and methane produced by the animals, and also N2O from either animal deposition of nitrogen on the field or fertilizer. In the tillage situation, it's really dominated, while on-farm emissions in both the dairy and in the livestock sector, 80% of total emissions are on-farm. It's a much different picture in the tillage sector. So really what you do see is that it's dominated by fertilizer from N2O application onto the field, by any manure application onto the field that might occur, and by fuel usage, and also then by the loss of soil carbon during tillage operations, be it ploughing, etc. But they only really make up around about half of the total carbon footprint of a product. Okay, so a lot of the emissions are actually off farm in the case of tillage. Okay, in terms of, so if we look at these nitrous oxide emissions first of all, certainly what our research has been showing is that in fact nitrous oxide emissions tend to be quite low actually from tillage soils, and that's because tillage soils are free draining, so they have quite low rates of denitrification. So nitrate preferentially tends to be leached. So the main loss pathway on tillage soils tends to be nitrate leaching. And in fact, so for example, when we did a lot of our trials looking at protected urea versus calcium ammonium nitrate, while we see very high emissions in grasslands of calcium ammonium nitrate, and hence our advice is to move to protected urea. In the case of tillage soils, we tend to see much lower emissions of calcium ammonium nitrate on tillage soils, again because there's a low amount of denitrification. But again, that nitrogen can be prone to nitrate leaching, so and protected urea again would be more protective from nitrate leaching than calcium ammonium nitrate. So that's the nitrous oxide story. The other story, of course, is soil carbon. And what a lot of farmers would tend to think, probably quite rightly, is that, well, you know, carbon is getting locked up by the crop, okay? And indeed, when a crop grows, say a field of winter wheat, for example, will fix about 12 tons of carbon per hectare. Okay, so 12 tons of carbon per hectare, that's roughly about 50 tons of CO2 for every hectare. Okay, and that sounds like that's a lot of carbon. Okay, so people ask then, well, oh, why is there carbon loss maybe out of tillage systems? And the simple fact of the matter is, okay, there's 12 tons of carbon being taken up by photosynthesis in the crop, but just under 5 tons of that gets immediately released via plant respiration. Okay, about 4 tons gets fixed into the grain, about 2 tons into the straw, and about 1 ton into the roots. Then when you plough, you actually remove the 4 tons of the grain, and you remove probably most of the 2 tons that's in the straw. You maybe have 0.4 of a ton of residue left over. The tons that's in the roots, those dead litter and roots then decompose. They emit CO2 as the microbes chomp away at that dead litter. It converts the litter into humus, and ultimately, and then a little bit is leached off, and ultimately you end up actually with very, very little being incorporated into the soil, roughly just under 0.2 of a ton of carbon. Okay, so most of the carbon actually that gets fixed gets lost along the way. Okay, so how can we influence soil carbon and increase it? Okay, so the first thing is that it's influenced by soil type. Okay, and if you think about a carbon sink literally as a sink, a very sandy soil can't really hold on to a whole lot of carbon. So it would be, say, the size of a washhand basin, whereas if you have a soil that has a high amount of clay, carbon can latch onto clay quite easily. And that would be maybe the size of a very large sink or a bath. And if you have a peaty soil where there's no decomposition occurring at all, it's like a swimming pool. So typically a tillage soil will have about, a brown earth will have about 80 to 100 tons of carbon, a clay soil maybe up to 200 tons of carbon, a peat soil up to about 2,000 tons of carbon per hectare. Okay, then if we look at land use, so how does land use influence? So what we generally tend to see across different soil types, from brown earths, clays, all the way to pod soils, is that essentially crops have the lowest amount of carbon, roughly somewhere in the region of just about around about 80 tons of carbon per hectare. And that's because the soil is being disturbed and being aerated. So the more oxygen you get into the soil, the more decomposition can occur. Also, there can be periods during which the soil is fallow, there's no cover on it. And again, that means that you just have respiration occurring, so carbon being lost out of the system without any carbon being fixed by plants. Again, so these combine to mean that croplands tend to have lower carbon content soils than undisturbed systems such as forest and pasture. However, there are ways to increase it. So adding manures, organic fertilizers, be it cattle slurry, pig slurry, farm manure, spent mushroom compost, poultry, can add somewhere in the range of about 0.4 up to over 2.5 tons of carbon per hectare. Okay, so again, this is an extra addition of carbon into the soil. And for every extra ton of carbon you put on in the soil, roughly between about 10% to 25% of it can stay in. Okay, and again, if we look at straw incorporation, again, where you can put in maybe about 4 tons of straw over 20 years, experiments have shown that you can get quite a substantial, an 8 to 10% increase in your soil carbon over a period of about 20 years. And again, cover crops reduces, so cover crops act in a number of different ways to reduce greenhouse gas emissions. They can, of course, catch nitrogen and stop nitrate leaching and help prevent nitrous oxide emissions. And then, of course, they also capture carbon while they're growing during that fallow period. So they can increase then the carbon content within the tillage system and make it more like an undisturbed system. Okay. And then, of course, there's minimum tillage. And now minimum tillage, again, while the interesting thing with minimum tillage is that while you see a buildup of carbon in the top of the soil there, in general, it doesn't make a huge amount of impact across the entire ploughing depth. It's mainly what you see as a buildup of soil carbon in the top, say, 10 centimeters or so, where you do see big increases in the impact of minimum tillage. Tends to be in countries where there's much more of a water deficit. And what you see is that because minimum tillage improves the soil structure, it improves soil water holding capacity. And that tends to be, seems to be the main effect that you see from non-inversion or eco-tillage. And then finally, you can also manage other features on your farm, such as hedgerows. So, in fact, what probably many people would think of as a very well managed hedge is actually, from a carbon point of view, a not very well managed hedge. And in fact, if you can allow your hedges either to grow taller or to grow wider, you can improve the carbon capture associated with those hedges by between 200 and 400%. Okay, so from about 0.2 of a ton of CO2 per hectare to 2 to 4 tons of CO2 per hectare. And again, if you can incorporate trees or woodland features, again, on a per hectare basis, you can sequester between 19 and 30 tons of CO2 per hectare. So just to round it off, if we can have a look maybe at a 100-hectare farm that's mixed mainly with spring barley, winter wheat, and maybe about 10% beans on the farm, what we can see is that the total amount of emissions from that farm would be about 800 tons of CO2. The emissions intensity would be very good, about 300 grams per kilo of grain being produced, and that compares to a kilo of greenhouse gases per kilo of milk, or 17 kilos of greenhouse gases per kilo of beef. So very, very greenhouse gas efficient. However, if you put cover crop straw incorporation on, you can reduce those total emissions down by maybe about a quarter. And in fact, a lot of the emissions are actually associated with nitrogen fertilizer manufacture and herbicide manufacture. So if you take those away, in fact, your on-farm emissions are about 250 tons over a 100-hectare farm. Okay, and if you plant then 4.5 hectares of forestry, say, and improve your hedgerow management, I'm assuming about 14 kilometers of hedgerows here. If you improve the hedgerow management, you can actually then end up in a situation where you are carbon neutral, or actually you're taking in more carbon than you're actually emitting. And that's so you know, there are pathways in terms of both land management, landscape management, and also crop management that can actually bring the farm emissions down to where you can reach carbon neutrality. So in the context of the future targets that agriculture are going to get, tillage is probably not in a particularly bad situation. There will be targets, probably separate targets within the Climate Action Plan for land use and land use change and improving soil carbon stocks. But for tillage farms, it is doable. It's important not only in terms of carbon sequestration and reducing greenhouse gas emissions, but also for increasing soil quality, increasing water holding capacity, cation exchange capacity, maintaining yield, and improving nutrient availability. Minimum tillage can increase carbon in the topsoil, but not necessarily down through the profile. Straw incorporation, rotations, cover crops, and also the incorporation of grass lays are effective at increasing soil organic carbon in tillage systems. One thing, though, to say is that this sequestration, it is reversible. If you move away from doing the practices that are that you put in place, it can reverse. And it's important then also to think about incorporating hedgerow management and maybe some woodland features into the landscape in order to achieve a carbon neutral farm. Okay, thank you very much.
Okay, Gary, thank you very much. My video is going to come up here now in just a second. So Gary, that's a really useful insight. I know we kind of ran through it relatively quickly, but it's there's an awful lot in that. There's a huge amount of detail in that took an awful lot of years actually to come together to actually get those figures in it. Just getting back a little bit to, we have a number of questions coming through there, but just getting back to the carbon, the zero carbon, if you like, or being carbon neutral on a farm. Is there much industry interest in us making that? Like if a farmer goes to the bother of doing all that, who's going to pay for it, if you like?
Yeah, and this is the $64,000 question. Certainly within industry, within the foods and drinks industry, it's very, very high on their agenda. The whole area of sustainability and sustainability from from an environmental, but also from a social responsibility point of view, is becoming it's going much more up the agenda of the big companies. If you look at the moment, nearly all of the large food and drinks companies, and in fact, all the large multinationals are employing, directors of sustainability. They're investing huge amounts of money in sustainability research. We see it across our food companies, for example, and the foods and drinks industry. Getting a carbon neutral pint or a carbon neutral loaf of bread is very, very high up the agenda. And really being able to prove that on farms is in fact, I suppose, one of the central tenets and one of the central driving factors of the signpost farms. So how can we work towards climate neutral agriculture? Now, for the tillage sector, that's probably not going to be too difficult. But for animal agriculture, it is going to be very, very challenging.
Okay, so if we go back then to the a tillage farm being able to trap more carbon than they're emitting. So if you like, we have, say, a tillage farmer has, in your example there, a number of tons. Are those going to be a valuable commodity to be traded, if you like? Can they be traded at the moment? And is there a prospect of that happening in the future?
Okay, so yeah, so at the moment they can't be traded, but there is nothing to stop either the government introducing a national domestic offsetting scheme. They're doing it in France. They're doing it in New Zealand. So there is the opportunity there. But there is also the opportunity for private companies, for example, to trade in carbon credits. So you see, for example, in the US, there's actually quite a vibrant carbon market out there. And there's loads of companies going around verifying the carbon credentials of farms. They're on to me now nearly monthly, particularly because we're setting up the series of flux towers across, our signpost farms and monitoring sites to verify how much carbon is actually being stored in our soils. So it is going to gain traction, and how valuable it will be will depend on the price of carbon. So the price of carbon on the emission traded sector markets at the moment is roughly about €50 a ton. So, if you're sequestering, 2-3 tons a hectare, that's €150 a hectare, so it depends on how the market will evolve, but certainly a market will evolve, because there's only one way the price of carbon is going to go, and that's up.
So Gary, just on that, is it so you came up with kind of a net at the very end for that farm? Is it the net bit that's traded, or is it the bit that you sequester along the way that's traded on a per hectare basis?
Okay, so it depends on what you're measuring and what your boundary is, but ultimately it should be the amount of so. For example, it should be the amount of carbon in if you put in a project, and the project is to grow 2 hectares of forestry on your land, it can be bounded by that single project. So it could simply be that 2 or 3 hectares of forestry, depends what you elect into it. You could elect the whole farm into it and make the whole farm carbon neutral. It ultimately depends on who's purchasing the credits. If it's for a single project, it can be simply a single field. If it is the government doing it, it would probably be across the entire farm and the entire enterprise.
We have a question here about the carbon loss through ploughing, which I think you said was 1.5 to 2 tons. I think that was in a diagram, and it's just one of the participants here is just didn't quite understand it. You might maybe just go across that again.
Okay, yeah. So there's kind of 2 or 3 ways that ploughing induces loss of carbon. And the first way is it breaks up the soil aggregates, so it exposes some of the carbon that's physically protected to decomposition. And the second thing it does is it aerates the soil, so it allows more oxygen down into the profile, and the microbes that eat soil carbon, they need oxygen the same way we do. So as you aerate the soil more, you get more accelerated decomposition. And the other thing that you do is you actually expose carbon that's been protected for quite a long time. So mainly carbon that's been sloshing around in the system for hundreds of years. You expose that to decomposition and replace it with carbon that comes and goes quite quickly. So there's actually 3 mechanisms by which soil carbon is lost via inversion ploughing.
Okay.
You know, and in fact, Michael, one of the things we're looking at is actually going to very deep ploughing, and actually trying to actually bury the carbon-rich topsoil further down.
Which is an impact in a grassland type situation.
Correct. Yeah.
Okay. I'm going to ask you this one, and I think the answer mightn't be overly simple necessarily because we're getting into all sorts of complexities. But anyways, do the forestry values that you put out there assume that the output, i.e. the timber, is fixed and secure as a sea storage method? So if timber output, so I'll just finish the question, Gary, and come in. And so if the timber output was just displacing timber from other sources and was not counted as a permanent store, how would forestry sea balance be affected? I know we're kind of getting into the forestry one, so you might keep this one.
Yeah, no, but that's okay. So the figures I quoted were for a 20-year-old forestry stand, and that would be the amount of carbon being sequestered per year by that stand. So what happens when forestry reaches, gets to clear felling? So the carbon is assumed to accumulate during the period during which the forest is growing. You get canopy closure, and then you either thin or you clear fell. So if you clear fell, the carbon isn't all assumed to go back up into the air. It enters a pool called harvested wood products. And those products, depending on what they are, be they furniture or be they put into houses, have different periods. They have different lifetimes. So when you cut down the wood in your forest, it's not all assumed to just kind of disappear up as CO2 automatically.
Okay. Gary, I'm going to ask you this one. It was asked in what are the main challenges of carbon in a mixed farming system, but I suppose maybe the real question here is that would a mixed farming system with animals and tillage involved in that, and perhaps forestry, you already said there, allow a more carbon neutral farming system?
Yeah, and the answer is probably yes, because if you have a mixed farming system, then you can rotate your grassland around the farm. So you can help ameliorate your soil organic carbon that way. If you can again bring some woodland features into it, we're starting some experimentation on agroforestry, for example, or again manage your hedgerows better, which will not only improve your carbon content of your hedgerows and your soil underneath, but the biodiversity of the hedgerows. If you can bring all these mixes together, if you can manage your manure well, and utilize your slurry instead of concentrating on mineral fertilizer, you can bring legumes into the system again to displace mineral fertilizer, then absolutely within a mixed livestock and tillage farming system, yeah, you can achieve carbon neutrality, yeah, or get very, very close.
Okay, I'm going to ask Gary you a last one. Sorry, I know Shay, you've been there patiently waiting in the background there, but all the questions are kind of directed towards Gary. So look, we'll get you in the end session. Gary, just one last question before we go across to Eddie Burgess. And the question is really about the amount of carbon taken up by different crops. Is there a direct association with the level of dry matter taken up by each crop? So the higher it yields, the more carbon it gets, or is it more complex than that?
No, it's more complex than that. And it's mainly more due to how long the green area index of the field is. So if a winter crop, for example, will capture more carbon than say a spring crop. So a perfect example would be maize, which of course has a very high dry matter yield, but actually loses more carbon out of that. You lose more carbon out of that system than you would say out of a winter oilseed rape or a winter wheat system.
Okay. As with all these things, they're relatively complex, and there's no simple answer for them. Really,
no, never is.
Gary, thank you very much for all of that and answering those questions, because some of them are tricky to answer in a simple kind of way, and you've done a really good job on it. We might ask you maybe towards the very end of the webinar, maybe you come back in again if there's another a question or two. But look, we're going to change a little bit now, and we're going to change over and talk about nitrates. And I'm delighted that Eddie Burgess could join us today. Eddie, you have worked in the agricultural catchments for a long time, so you have a really deep insight, if you like, into the interaction of the agricultural activity and the water quality associated with some of those catchments, if you like. So obviously, there's lots of changes coming down the line in terms of the nitrates directive. And I think maybe even more immediately, the fact that fertilizer prices have jumped so massively in the last year or so, this should really be to the forefront of everybody's mind. So Eddie, I'm going to put the floor across to you, and you might give us a presentation. Thanks, Eddie.
Thanks very much, Michael. And I do think it's very appropriate that we're talking about nitrate now, following on from Gary's presentation with the carbon. That they are very, very much linked, and the ratio between carbon and nitrogen in the soil or in manures that are being applied or in green matter getting plowed down has a huge influence on what happens. So they do link very much in the influence on the environment. As you've mentioned, Michael, I've been working with the Agricultural Catchments Programme, and we've been monitoring water quality across 6 catchments for over 12 years now. And there are many aspects to water quality, but today I want to focus on just one of them, and that is on nitrate and nitrogen. Okay, so the main focus of my talk today, really, and to give a bit of a background, I want to talk about where nitrogen causes or can impact on water quality and what those impacts are. Why is it of a concern? What are the regulations? You mentioned that the Nitrates Action Programme is currently being reviewed, and I want to go through the European regulations that are put in place to minimize nitrate loss into the waterways. Where tillage farming fits into all of this, and what tillage farmers can do to minimize or reduce nitrate loss into our watercourses. That's the main focus of what I want to go through. So starting off immediately, high levels of nitrate in drinking water will cause health problems. That there's a syndrome, blue baby syndrome is deemed to be more likely to occur if your drinking water has above 11.3 milligrams of nitrogen from nitrate in it. So that's a drinking water standard, that 11.3. And that is written into the Nitrates Directive, which has been in place since 2006. And by and large, water quality in Ireland is good in this regard, and is well below the 11.3 figure. Just to be conscious, there are different scales. I suppose a bit like if you're talking about fresh weight and dry matter weight, 11.3 is the figure measuring just nitrogen. If you're to measure the total nitrate, the equivalent figure would be 50. So some people might be used to a figure of 50 as a drinking water standard. It's a different scale. I'd compare it to weighing fresh weight of silage or just the dry matter of silage. It's the same thing. 11.3 milligrams of nitrogen is the same as 50 milligrams of nitrate. it confuses everybody, but I'm going to stick with the nitrogen scale here and the 11.3 limit. And we're good in Ireland, and we're a lot better than most other European countries. And a lot of our drinking water comes from groundwater, from wells, and my own at home here being an example of that. And the EPA are monitoring groundwater across the country for the Raw Water Framework Directive. And 98% of the groundwater in the country is below that drinking water limit. So we do have good quality nitrate levels for drinking water, and we're well within the Nitrates Directive standards. But to take it a bit further, nitrogen also has an ecological impact. It impacts on the biology in waterways, and it can cause a thing called eutrophication, which is excessive algae growth. And mostly nitrogen is the limiting nutrient for you that will cause eutrophication in salty type water. So we're talking about in the marine or in the sea and in the estuaries, where you're into the tidal zone of watercourses. And this has been measured to meet requirements under the Water Framework Directive, and also ecology is mentioned in the Nitrates Directive, European regulation. And in comparison to a lot of European countries, our figures are still good from this regard, but a lot of our water bodies don't meet the required standard. On the same scale where I mentioned we had a drinking water standard of 11.3, the ecological standard or the environmental quality standard EQS is 2.6 in our estuaries. So for example, if you're on the River Slaney and you go below the weir in Enniscorthy, you're getting into the tidal water. If you go just below that weir, take a sample. If the nitrate level is above 2.6, it is not reaching the standard required under the Water Framework Directive. And there are 5 different categories of standards. There's high, good, moderate, poor, and bad, depending on this concentration. And to reach the good status, which is what we're looking to achieve, it needs to be below 2.6. If it's the high status, it's below 1. Okay. And if the nitrates get into our estuaries, and you can see on the map here in Europe, the Baltic Sea and in the North Sea, so coming out of countries like Denmark and Sweden and Poland and North Germany, and also in Holland, the nitrate levels are much higher than they are around Ireland and on the west coast of the UK. Having said that, we are in the European Union, and European regulation that is brought in to try and minimize nitrate applies to us equally as much as it does to other European countries. And it does cause algae growth. And this is a satellite picture taken of the Baltic Sea, and you can see the colors here of algae growing in that region. But it doesn't just occur there. On the south coast of Ireland, this is a picture taken and presented by the EPA, and it's showing an algae growth that has washed up on the beaches in the south coast, and it's been removed by the local authority down there. And that has been an annual occurrence on some beaches. I think of note and of interest here, a similar occurrence has taken place in Brittany. They have quite a large nitrate problem in Brittany in France, and some of these algae can be toxic. And this was happening for quite a long time. And then one year, some horses got onto the beach and they ate the algae and they died, and there was a major media backlash to it, and the agriculture suffered as a result. So media and in the influence of it can have fairly strong impact. The EPA are monitoring water quality across the country for the Water Framework Directive, and in recent years, the focus of their water quality monitoring has been on nitrate and on nitrogen. And they have said that the problem is very regional. It's in the east, south, and southeast of the country. And they have very clearly said that this region coincides with the area where there has been the largest expansion in dairy cow numbers and the largest degree of intensification in stocking rate and nitrogen application rates. In addition to that, and from our findings in the Catchments programme, this region of the country also coincides with free draining soil types and coincides with where we have drier summers. Like, for example, in 2018, I'll come back to that, the east, while we had a great summer in the whole country, the east was much more, much drier, much less rainfall than in Galway and Mayo, for example. And all these graphs and figures I'm presenting now on this slide are from the EPA, and they have compared the rivers that are low in nitrate and the amount of nitrate leaving those since 2008. And here's the amount of nitrate leaving the rivers that in the south and east of the country and the regions that were brown on the previous map. And they have said that since 2013, there has been an increasing trend in nitrate losses. And there is a lot of focus on this. From our point of view in the Agricultural Catchments Programme, I mentioned that we're monitoring water quality in 6 catchments around the country, and they weren't selected at random. They were selected to represent different soil types and different farming systems. And we have been taking water samples every 10 minutes from those catchment areas. They're not large, they're roughly speaking around 1,000 hectares. And if we look at the nitrate figures from the one in West Cork, which is a predominantly grassland dairying catchment, and the 2 in County Wexford, one being predominantly spring malting barley, and one being, again, predominantly grassland, but slightly mixed in Ballycanoe as a Macklemore type soil, a heavy soil. So we have 2 free draining soils and 1 high clay content heavy soil type. And we look at the nitrate trend in those going back to 2016. This is the monthly average. We've kind of averaged out our figures that we're taking every 10 minutes into a monthly average. And you can see there is a marked difference between the Ballycanoe catchment with the heavy soil and the other 2 free draining soil types. And we would expect free draining soils to have a higher nitrate concentration in the rivers draining from them. The top line here in the dotted line is the drinking water standard, 11.3 milligrams per litre. And the dotted line here that you can just make out on the bottom is the ecological standard, the 2.6. Okay. So the heavy soil where in Ballycanoe, where most of the rainwater gets into the stream by overland flow, nitrate is not a problem. In the free draining catchments where they're spring fed, nitrate levels are high. But this is the amount of nitrate leaving in the catchments, but the amount being applied and going onto the farm, be it either via stocking rate with organic manure and applied chemical fertilizer, is approximately 3 times higher in the Tillage catchment than in the Castledockrell tillage catchment. So it doesn't always follow that reducing the amount of nitrogen that's going onto the land will necessarily reduce the amount of nitrogen leaving the land. And our findings in the Catchments programme time and again show that it's not as simple as saying that the load being applied equates to the load of nitrogen leaving the catchment. The load of nitrogen being applied in Ballycanoe is also higher than what is on in Castledockrell, and they have the same weather. Okay. So again, here's a table just going through the results from those 3 different catchments. The Ballycanoe in high clay content was about 1 metre of rainfall. About half a metre goes up in the air through evapotranspiration, and in the stream leaving that, there's about half a metre flows out in the year. And the stocking rate in the Ballycanoe catchment from livestock is on average over the catchment is around 100 kilograms of nitrogen per hectare. And the concentration is just below the environmental quality standard. If we multiply the concentration by the amount of water, we can figure out that on average per hectare in the catchment, we are losing just over 13 kilograms of nitrogen per hectare. In the Castledockrell catchment, which is predominantly tillage, we go through the same. We don't have as much livestock in that catchment. The nitrate concentration is quite high. It's the highest of our 6 catchments. It's above the ecological status in the estuary. Now, we're not in the estuary in our catchment, but we're above that standard. And the nitrate loss per hectare over the 12 years is just under 40 kilograms. And in Timoleague, it's very similar. The concentration is slightly lower. There's more rainfall. And because there's more water leaving the catchment per hectare, the number of kilograms per hectare leaving is slightly above what's in Castledockrell, but I'd say that's really not significant, the difference there. So the point really I'm trying to make here is that the soil type has a huge influence on nitrate loss via the waterways, and often overrides the farm practice. Okay, so where and when is and how really is nitrate lost to water? Nitrogen, when it's in the soil, it dissolves very easily. It's very quick to dissolve in water. So if you have a soil type where the water will percolate through the soil and move downwards after rainfall, it'll dissolve in that, and it ends up in the streams via springs coming from groundwater. And it could take some time for that to happen. In a free draining soil, water will move quickly, and the majority of the water in the stream, I would say in Castledockrell, is about 2 years old. In other words, I'd say it's 2 years since that fell out of the sky. In the Timoleague catchment in Cork, we'd say probably would be closer to 5 years of age on average. And in Ballycanoe, it could be significantly more, be 10, 15 years old. So there is a lag period from when rainfall falls, percolates through the soil, picks up nitrate that was in the soil, and arrives in the spring, feeding the river. If we have a surface runoff catchment and we have heavy rain, you'll see a river going into flood quite quickly, and it could be only a matter of minutes or hours before that rainfall ends up in the river that we're monitoring. And in a runoff scenario, phosphorus is the element that's of more concern. And it often happens that it's very contrasting. The 2 nutrients that impact on water quality are nitrogen and phosphorus. And usually where nitrate is a problem, phosphorus isn't, and vice versa. Okay. Again, coming back to the nitrogen load that's being applied to the land. Often there is a direct correlation being insinuated that just because you've increased your intensity and you're increasing your nitrogen application rate, they're definitely going to lead to an increased nitrogen loss. That's not necessarily the case. It's nitrogen that doesn't get used by the growing crop that's available to be lost. If you're very efficient in your nitrogen use and you have very high yields and you have very high offtakes, then you have good nitrogen use efficiency. You don't have much surplus nitrogen being left to get leached, or maybe negative amounts. Maybe you're leaving less nitrogen than was there before you grew the crop. Then it's the surplus nitrogen we need to be concerned about rather than the overall nitrogen application. From a tillage perspective, soil will release nitrogen once the temperature is above 5.5 or 6 degrees. Gary mentioned a lot about the microbes in the soil, and they will release nitrogen. And that nitrogen, while it's not applied, is also available for leaching and can be lost to groundwater. And from 1 year to the next, if the soils are dried out, for example, in 2018, I mentioned the soils dried out and that were followed by heavy rainfall in the autumn, and nitrate that was naturally mineralized in that soil got leached down into the groundwater, and it led to higher levels of nitrates across all 6 catchments, higher than we had ever seen heretofore. The Ballycanoe catchment, I mentioned, has a heavy soil type and it's more prone to be waterlogged. And if you have waterlogged saturated soils, you have anaerobic conditions, and the bacteria and microbes that live in anaerobic conditions will remove nitrate from water and release it into the atmosphere. This is denitrification, again, also mentioned by Gary earlier. And also, if you're in areas like in the west of the country where you have more rainfall, there is a direct dilution effect, and the concentration of nitrate will be lower where you have more rainfall leaving in the rivers. So really, nitrate is often called, I've heard it referred to as the maverick element. It doesn't always do what you expect. Coming back to the tillage scenario, I'm just trying to keep moving here. I'm going on a little bit long, but when you have a growing crop, it will, as it's growing and you have green material there, it'll take up nitrogen. Soil will release nitrogen right throughout the year, so long as the temperatures are above 6 degrees. And in the tillage situation, at this time of the year, quite often there are no crops growing to take up this nitrogen that has been naturally released from the soil, and it is available for loss by leaching at this time of the year from now on, when it starts to rain and water tables begin to rise. So this is where catch crops are coming into play. And for quite some time now, Richie Hackett and Carl Richards a long time ago did some trial work in Oak Park, and this type of work has been continuing. But back in the early 2000s and mid 2000s, they compared different cultivation systems with no cover crops, and really there wasn't much impact of using conventional ploughing or reduced tillage systems. But the main reason I'm putting this slide up here is to show that there was a massive difference between one year and the next. So the weather does have a huge impact on nitrate losses. When cover crops were thrown into it, you can see that they did have a big impact, and they reduced the nitrate levels significantly. So they are having a big impact on reducing nitrate losses where they go in on time.
Just a couple of minutes there, Eddie.
Yeah, okay, Michael. I'm nearly done here now. Some work done by Richie this year was just showing the impact of sowing date on catch crops. Sorry, last year. And one sown on the 30th of July had very significant growth. And in August, 3 weeks later, also was also significant, but there was a marked reduction. And really what Richie was saying here is that there was 2 tons per hectare of a difference for every 3 weeks delay in sowing time. And Richie put together a video on that, and I'd recommend that you have a look at it. It's very graphically displays the difference in sowing date. And you don't have to sow a catch crop. Natural regeneration, if it's encouraged quite quickly, will also have an impact. So in summary then, I'd just like to from a tillage farm's perspective, the good aspects from tillage is that, from my experience in dealing with the farmers in the Catchments program and in general, tillage farmers are very interested in nutrient management. They're not spending excessive money on nitrogen where it's not needed. They have the soil pH and soil fertility in good stead, and this has been shown in National Soil Surveys from Mark Plunkett and likes, and also we're discovering that in our own catchment. So nutrient management is done well, and nitrogen use efficiency on a tillage-based system is between 70 and 80, maybe even higher % in comparison to grassland-based systems where it's 25%. So this is all good in terms of reducing nitrate losses. The problems that we're trying to deal with is, unfortunately, as I've outlined there, a lot of tillage crops have a short growing season. Soil is releasing nitrate itself naturally, and if there isn't a crop growing, then that nitrate that's been released naturally is available for loss. Tillage takes place on light soils, which are more prone to nitrate loss. Because tillage farmers are already doing an excellent job in nutrient management, the number of extra things that we can do to try and minimize nitrate loss are quite few. And there is a lot of uncertainty because of the weather impact. The biggest action that we have come up with is through early establishment of a green cover, be it either natural regeneration or a catch crop. And this does cost money, both in establishment and in removal. it doesn't necessarily lead to any reduction in nitrogen use in subsequent years. So what does this all mean? Unfortunately, the EPA have established a trend, an increasing trend in nitrate. And at the moment, we're at the end of a cycle for both the Water Framework Directive and the Nitrates Action Programme. And it's been reviewed, and there are actions, and I suppose there is a focus on tillage. It's not just on the grassland sector. And I think it's important that we're aware that tillage is being discussed. And the things that have been highlighted in the nitrates review are of relevance to tillage. The biggest one, I think, is the 7 days to try and establish a green cover on tillage ground 7 days after harvest, but also saying that the closed period for spreading of slurry will be brought back to the 15th of September. And they're also looking at the increased chemical nitrogen allowance that was given to malt and barley, and for higher yields and for milling wheat. In addition to that, there is proposed a register for fertilizer purchases in 2 years' time, and buffer strips for late harvested crops, and also a degree of focus on compliance farmers. So the nitrates review takes place every 4 years, and to date, most of the changes in the nitrates have been favourable and have been a relaxation of the rules. This year, I think that's going to change. Okay, before I finish up, I'd like to acknowledge the cooperation and work with the 300 farmers that we're dealing with in the Catchments programme, and also our funders, the Department of Agriculture, and people that have been working with. Thanks very much.
That's great, Eddie. Thank you very much. You might stop sharing your screen there, and I'll invite you maybe to answer a few questions. And I think we have Shay Phelan is coming in there as well. Eddie, there's a number of questions after coming in here, and we'll try and get through as many as we can. The first one I just want to ask you is that in terms of what you're after telling us here today, it probably changes the narrative just a little bit. I suppose an awful lot of people, certainly in the tillage industry, would maybe look at the dairy industry or the livestock industry in terms of they have increased their area, tillage area has gone down. So why aren't they mostly in the firing line here rather than the tillage farmer?
Yeah, I'd say they are, Michael, to be honest. We're working a lot with the nitrates review document at the moment, and I've came back from Moore Park, had an open day, have today, and the previous 2 days I've had an open day, and all the discussion is on sustainability and the review of the Nitrates Action Programme. And the couple of changes that I've mentioned there are significant for the tillage sector, but there are a lot more changes coming down the line for the livestock sector in general, but more specifically for the intensive dairy farming under derogation. And the derogation is the term derogation. I think people don't realize derogation is a derogation to the rules. It has to be applied for, and it has to be approved. It's not a given, and the derogation may not be approved.
Okay. So just one of the main measures you identified there is cover crops. I just wanted to come to Shay here for a second. Shay, when cover crops go in, how much of the nitrates, or how far does that go in terms of lapping it up? And I suppose the other small question with it then, if a farmer grazes that cover crop before the end of the year, does that impact on the nitrate leaching, if you like?
Yeah, it's a good question, Michael. It's kind of like a piece of string. How long is a piece of string? So if you take it, yesterday was a closing date for last catch crop sowing. So if you're putting in at last catch crop yesterday, chances are it's not going to take up too much. It's not going to mop up too much nitrogen from now to the end of the season. Plus, you also have to factor in that since the crop was removed, like Eddie showed earlier on, that there is nitrate being leached when the crop has been removed, so it's not going to take back up that nitrate. So ideally, with catch crops, the earlier you can get them in, the better. And ideally, in a situation where, say, something like winter barley, if you're going after winter barley, you can. And I've seen crops at the moment where there's fodder rape and fodder kaolin, and if we can use the measure like that have a GAI of over 1 at the moment. So if you take at that in that scenario, they have nitrate levels in that crop of about 50 kilos a hectare. So in that scenario there, they've already taken that nitrate risk out of the equation already, because the nitrate is actually stored in the crop. So in that scenario, yeah, there's huge capacity there, but it depends on the catch crop when you sow them and the type of catch crop you sow as well. From the point of view then of grazing them, like those crops that are sown, those fodder rape, fodder kales, they are sown. If they are grazed off pre-Christmas or shortly after Christmas, obviously that nitrate is, the crop is transformed into nitrate, and the urine and dung that's left behind by the animals. And that is a potential that there is potential that can be lost to the system again, I suppose. But obviously, the closer you graze them to a crop being sown in the spring, the better from that point of view, from the risk of nitrate or nitrate leaching. So ideally, if you can leave to grazing until after Christmas, it's probably better from that point of view.
Okay, Eddie, can I come back to you? Cover crops, I suppose, are the main one that you identified. Is there any other measures that a tillage farmer can put in place to help reduce nitrate losses?
There is, and they're doing them all, Michael. Good nutrient management, having the pH right. The main one, avoiding excessive nitrogen. It's the surplus nitrogen that causes the problem. I'm not saying not to put out what's recommended, but if your pH is incorrect, or if your K levels are low, trying to compensate by going out with an extra 20 units of nitrogen is not the way to fix it. You need to get the overall soil fertility correct in the first place. And my experience is a lot of tillage farmers are doing that.
Okay.
Straw incorporation measure that's in now and planning straw in, that may soak up a lot of nitrogen that's in the soil. I talked about the carbon nitrogen ratio and the breakdown of the organic matter in straw that gets incorporated. The microbes in that will take nitrogen out of the soil for them to grow, to break down the straw there. So that could be a benefit from a nitrate leaching point of view as well.
Okay, I'm going to ask you one final question, because we're just a little bit over time, and I apologize for that. We'll maybe another 5 minutes or so. As regards nitrates, is it possible to get to, if you like, zero or close to zero in terms of nitrates in the river? And I suppose in the same regard, do we have a handle on what the background nitrate leaching is, even if we didn't do intensive agriculture?
Yeah, that's a very good question, Michael.
Sorry, no,
I'd say no is the answer. We don't know what the background level is. The EPA have highlighted a trend of increasing nitrate levels. In my opinion, a lot of that is driven by the changing in weather pattern, the drier summers followed by wetter winters that flush out nitrogen that's mineralized there. Crops receiving no nitrogen, like beans, are probably ironically a higher risk for nitrate loss than crops that have a lower nitrate use efficiency, like oilseed rape, because of the growth pattern of oilseed rape at this time of the year is soaking up mineralized nitrogen that would otherwise have been available for loss. Organic farming is prone to nitrate loss via leaching. Clover is often put out there as an excellent nitrate nitrogen environmental crop. Again, nitrate fixed by clover is just as prone to loss by leaching as nitrogen coming out of a bag. So good nutrient management practice and not putting on the excessive amount, applying it when you have growth to take it up, are key to minimizing losses.
You're on mute,
Sorry,
Michael.
Eddie, thanks very much. There is a number of other questions. We're just not going to get around to them all, and we're going to try and answer them there as we just by typing the answers in here. But Eddie, look, thanks very much for your contribution. It was it's really timely, because I think the nitrates rules, I suppose, are going to change. It will affect all tillage farmers, especially around the southeast. So people really need to be on top of what's coming down along the line. So again, thanks very much, Eddie.
Just to say on that, Michael, the nitrates review, there's a consultation process taking place at the moment, and if the tillage farmers feel that there are proposals in there that are not practical or can't be implemented, or if there's something missing that should be in there, the Department of Agriculture and the Department of Housing, who implement the nitrates regulations, are looking for written submissions on that. And now is your opportunity to make those.
Okay, thank you very much. And Shay, thanks very much to you as well for your contribution. And Gary, I know, is there in the background somewhere as well. Gary, thank you as well. It's been a really good insight into those kind of fairly major areas. And I suppose, look, at the end of the day, there are changes coming. Farmers need to be need to be up to date, if you like, in how they're going to think about these and how they're going to think about changing their farming systems around those. So, look, with that, I'm going to nearly sign off. There's just a couple of things I just want to say before we leave. We are coming, thankfully, towards the end of our COVID lives. So hopefully we're kind of getting out the far side of that. And because of that, I suppose we're all heading back to normal a little bit. And because of that, then next week, we have a number of different things on in terms of Teagasc. So there's a slide there I think you might flash up. We have some autumn crop walks coming up next week. So this is really going to look at some of the autumn management in crops, such as herbicide or weed control, BYDV control, the use of nutrients on farms at this time of the year and how to manage them, especially given the price of fertilizer at the moment. And there's a few other topics going on locally in terms of hedgerow management and that kind of thing. So on Monday, we're down on Monday the 20th, that's next Monday coming, we're down in Tom Barry's in Cork. Tuesday, we're in Donald McGrath's in Clonmel and Tipperary. Wednesday in Simon Neville's in Wexford. Thursday in Tom Tierney's in Kildare. So all of the events start at 11 o'clock, except Kildare, which starts at 3 p.m. The other thing just to point out, and we have a really quick webinar, if we can just flick on one, a very quick webinar on Monday morning. And again, we're targeting a specific area here, so it's thought to be really, really targeted. It's on winter malting barley. So we are going to start it on Monday at 10 o'clock. Short webinar, about 30 minutes. Richie Hackett is going to give us a little bit of an update on some of the research that's been going on over the last year or so. Owen Lyons then is going to give a little bit about, I suppose, the overall agronomy and grower experiences, along with John Crowley and Tom Bryan from Bournemouth, because this is in conjunction with Bournemouth. Will give us a bit of an insight as regards what's available for the season. So look, that's really about it for us today. I really want to thank everybody, our speakers again, and very much thank the participants for asking questions. I hope that we got around to most of them. I think we probably have. Last kind of couple of things, I just wanted to thank Dara in the background, who's kind of helping us out, trying to keep the kind of show on the road with Zoom and all these kind of things, which is great. And maybe the very last thing is that we have a survey that going out to, we're going to send it out to everyone who tuned in today. And that's really around just getting a bit of feedback from yourselves as regards how do we do it better, what bits do we need to improve, etc. So that will be sent out to you hopefully in the next half an hour or so. It'll only take 1 or 2 minutes maybe to complete it, but it really does help us in the background. So with that, apologies, we're a little bit over time, but look, goodbye for now, and hopefully we'll see you next time. Thank you.